So to find an inverse, we switch y and x, and then we solve for y. There's some extra little details that we want to make sure with the domain range. Look, basically, the domain of this function should be the range of your inverse. The range of whatever this function is should be the domain of the inverse. But with a lot of these problems, that little detail doesn't matter. We just want to solve for y. So I'm going to multiply y to the third plus 1 to both sides, because that will get it out of the denominator here. But I got to do the same over here. So this is x times y to the third plus 1. And that equals 1. So we can distribute that x. Can subtract this x from both sides. Trying to get y by itself. So I'm going to divide x from both sides. And then last step here, trying to get y by itself. So that's sorry, that's x to the third. So you could cube root both sides, which is the same thing as raising both sides to the 1/3 power. Either notation is fine. So there's our answer. The inverse is the cubed root of 1 minus x over x. And then to verify it's an inverse, you got to plug this back into the original function, because an inverse, if it's substituted into the original function, so this is inverse notation, it should give you the identity. It should give you x. So if I'm going to plug my inverse in back here, my inverse was the cubed root of 1 minus x over x. And that's all being cubed. And then if you simplify that, cubing a cube root cancels out. So I need common denominators to add the 1 in this rational expression. So I'm going to make that x over x. And so if you add those together, the negative x and the positive x cancel out, so you get 1 over x. And then if you have 1 divide by 1 over x, that's x. You would flip and multiply this fraction. So we just verified it.